Hey there, C# friends. My name's Matthew. I'm the C# artisan, and this is the second video in my series on nullable reference types. In the first video, we asked the question, what is this feature for? What is the purpose of having nullable reference types? And the answer is that this feature attempts to help us prevent null reference exceptions. And it's going to do it by providing some helpful compiler warnings that point out possibly unsafe code. So in this video, we're going to dig into the details. We're going to first review a little bit how static analysis works. We're going to talk second about why the C# compiler has a bit of trouble spotting these possible null reference exceptions. And third, we're going to introduce the concept of annotations. Annotations is how we're going to give the C# compiler a little help, some hints that it can use to more correctly and accurately identify possible null reference exceptions. So this concept of annotations, I think it's brand new. I've not seen anything quite like this anywhere else in C#. And the way it works is you add a special character, almost always a question mark, though occasionally an exclamation point. You add this special character as a suffix on a type. And it doesn't really change the type under the hood, but it provides the compiler with a little more information that it can use, kind of a hint that it can use to correctly do the static analysis. Okay, so that's very abstract. Let's get right into it, and we'll start off by just reviewing how static analysis kind of works and what we wish it would do to help us spot null reference exceptions. The term static analysis refers to the process of analyzing code without executing it in order to find possible issues like possible bugs, security vulnerability, violations of coding standards, code quality issues, that kind of thing. Now, if you use Visual Studio, you experience static analysis all the time. The C# compiler is doing a lot of it on the fly. Let's take a look. What if I write this line of code? Int I equals 3. Do you see how we get this little squiggly line under the variable name? Let me go ahead and build this. And what you see down here is this compiler warning, CS0219. The variable I is assigned, but its value is never used. So that's an example of static code analysis giving you a warning. Let's do one more. What if I put a return statement right there? Do you see how console is underlined at that point? So let's go ahead and build this again. And now we have another one, CS0162, unreachable code detected. So when it comes to null reference exceptions, if we look back at our Polygon class, I've put it back to the unsafe version. Wouldn't it be nice if the compiler pointed out this line of code and said something like, hey buddy, you might be dereferencing a null right there? That would be helpful. So why doesn't it do it? Why doesn't C# do this by default? So to explain that, I need to talk a little more about object variables or reference types, and I want to introduce the concept that they come in two flavors. That's not really a technical term, but you'll see what I mean as I write out these examples. So let's start now by let's define a list polygon. And we can just initialize it. And now let's declare a variable, polygon poly equals polygons dot find. And we'll say p dot sides equals 8 for our find condition. So this is going to look in our list of polygons and see if it can find an octagon. So the reality is that this variable, poly, might end up being null. If the list of polygons does not contain an octagon, then after line 14 executes, poly will be null. That's expected. Now compare it to this. Let's say polygon poly2 equals new. And in this case, we'll say sides equals 8. That's fine. And now we'll do something like int I equals poly2 dot sides. So this time, we can say this variable, poly2, will never be null. We know that. So if we were to write code here, int x equals poly.sides, this is unsafe. Poly might be null. Whereas this is safe. Poly is never null. So those are the two flavors of reference type variables. Sometimes the variable could legitimately be null, in which case you want to check for its null status before doing something like this. Sometimes, however, the variable will never be null. You know it's safe, and you don't need to put in the additional null check. Let's do the same comparison with strings. So I'll just type the comment first. This variable so I'm going to declare a string called setting equals environment dot get environment variable. So right now, setting might very well be null. If the environment doesn't have this environment variable, then setting will be null. And so if we do something like int j equals setting dot length, this is unsafe. Setting might be null. And for comparison, this variable name will never be null. So we can say string name equals string dot concat Fred null frog. So how do I know that this won't return null? So the string concat function will accept any number of strings and it concatenates them together. And if you pass it a null in the list of strings, it just ignores it. And it will work just fine. And if you pass it all nulls, it returns string.empty, but it never returns null. So now if we say int y equals name.length, this is safe. Name is never null. So again, we have now two flavors of reference type variables. Those that might be null and need a null check if you're going to dereference them, and those that will never be null. So why is this important? Well, if we were to magically turn on a feature that allowed the C# compiler to point out every single instance where you reference something like poly.sides or name.length, what would happen is all of these situations where it was perfectly safe would generate false positive warnings. You'd get the warning you want here, but you'd get a false positive here. You'd get the warning you want here, but you would get a false positive here. And the problem is this might just swamp your output window with just hundreds and hundreds of false positive warnings. So up until C#8, the C# team just took the view that, well, null checking is the programmer's responsibility. The compiler can't really provide a lot of help here without overwhelming you with false positives, so it's your problem. It's up to you. And most of us learn this and we look at our code and we write the appropriate null checks. So with nullable reference types, we get this new concept of annotations. And annotations lets you tell the compiler which reference variable might be null and which reference variable is never going to be null. It's a little hint, a little help to the compiler to tell it which ones to check and which ones not to check. So here's how you do it. For a variable like poly, which might very well be null, you add a question mark after the data type. So now this is polygon that could be null, poly. For this one, we leave it alone. We just let it be a polygon, and that tells the compiler won't be null. Same thing with strings. If we put a question mark here, we are now saying that this string might be null, and leaving this one without the suffix tells the compiler this one will never be null. So now the compiler would give you a warning here and would give you a warning here, but won't give you a false positive here or here. Now, if I build this, you're going to see some new compiler warnings, the CS8632, which means, well, you can't do annotations for nullable reference types unless you have the feature turned on. We don't yet have the feature turned on. So that's coming in a future video where we actually enable the feature and start examining the kinds of warnings. But for right now, the key takeaway, the one point is you have this new thing you can do in C#. You can annotate your reference type variables with a little question mark suffix that tells the compiler, hey, this one could be null. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.